Hello, and welcome to another lesson with Professor Checo. Today's lesson will be the table method, an introduction to the simplex method. So let's go and take a quick peek. Boom. And let's go straight to the textbook. Textbook. All right. So in chapter 5, we basically use variables to x and y in order to set up equations with that. In this chapter, we're going to use letters with subscripts like x1, x2, x3 being x, y, and z, so forth, to denote variables. With the new notations, we'll lay the groundwork for linear programming and show this method. So the standard maximization problem standard form will look like maximize that the profit is 50 times x1 plus 80 times x2 subject to these conditions, and then we got to try and figure that out. So the definition of standard problem is definition is the standard maximization problem in standard form. A linear programming program is said to be standard maximization problem in standard form if the mathematical model is of the following form. To maximize the objective function c1 x1 and just basically multiplying that, it would be your profit. So from there, we're really just going to kind of work it out and talk about all those corresponding points, and then is the procedure. So you use slack variables S1, S2 to convert the I system into an E system. I'm not exactly sure what the difference between an I and an E system is. From the table, you create that many rows, that many columns, label it, complete each row to the E system, and that. So forth and so forth. So I'm going to be coming back a lot to this textbook because I'm not exactly sure what this method is. If the optimal value of the object function in the linear programming model exists, then the value must occur at one or more of the basic feasible solutions. Yeah, that makes sense. We basically check all our endpoints and turning points to find out which value gives us the highest thing. All right, table method going through, and going through. All right, so here. In order to find the benefit of the table method is that it gives the procedure of finding all corner points of the feasible region without drawing a graph. Interesting. So for example, if k equals 30 decision variables and m equals that, then it's 35 c 30. All right, let's get out the textbook and let's just give this a shot. So in how many ways, let me zoom in a little bit. In how many ways can two variables be chosen from x1, x2, s1, s2, s3, s4, s5, x6? So here I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 variables, and I'm only going to be choosing 2 of them to be our solutions. So over here, this is a combination. So if I have 8 people and I'm choosing 2 of them, 8c2 would give me an answer of 28. So how many possible answers are there? There should be 28 possible different ways. In how many ways can the 2 variable be chosen from? 1, 2, 3, 4, 5. So 5c3. So I'm going to go here. I'm going to go to 5. I have 5 options, and I'm going to choose 3 of them. And that one's going to be 10. So here, there are 10 ways that we could solve these solutions. All right, so find the solution of the system equation for which x1 equals 0 and s1 is equal to 0. Then this is 0, 0. That means that x2 is equal to 7, and s2 is equal to 0, 0. What's 48 over 5? I don't know what that is. I'm not exactly sure. I'm gonna have to go with you guys. I did all that. Oh, and then just plug it in. Oh, you bobo. Okay, so hold on. I got that x2 is equal to 7. 7 times 5 is 35. 48 minus 35 is 13. 48 minus 35 is 48 minus 35, 5, 6, 7, 5, 6, 7, 8. It should be 13. 7. Oh, wait, 27. That's not 7, that's 9. And then 45, that's 3. Okay, I'm understanding this a little better now. So let's try this next one. So I want to maximize this. Write the associated linear equation for the inequality, boom, using S1 as the slack variable. So do I just write this equation? Do I do 7x subscript? Let me see the example. I think they're just looking for oh, 7x1 plus 4x2. How do I get subscript? Control down here. x2, what is that going to be? Plus s subscript 1 equals 14. I think that's my first equation. My second one is going to be 6x1 subscript 1 plus 3x subscript 2 plus s subscript 2 is equal to 13. Cool. All right, write the associated linear with this inequality, use S1. So I'm guessing this is going to be the same exact thing. So I'm going to go to show completed. And let's see, we have the first line is going to be 12x subscript 1 minus 15 plus S2 is equal to 52. Right there. Second one is 17 plus 4x2 plus subscript 2 is equal to 41. And here, negative 9x plus 10x2 plus S3 is equal to 61. All right, yeah, that makes sense to me. Moving on. Right, so for this one, use x1 as the slap variable. So I'm thinking it's going to go into our second equation because the second equation is the one that is less than. So let's do 4x subscript 1 plus 5x subscript 2 plus s subscript 1 is equal to 25. I believe that's what they're looking for. Yep. Okay, table below shows the 6 basic solutions to the following equation. Is basic solution A. In basic solution A, which variables are basic? I think x1 and x2. X subscript 1, comma, x subscript 2. No. In a basic solution associated with the linear program, the variables that are assigned the value 0 are non-basic. Oh, so S1 and S2 are basic variables. Okay, because they are basic variables. Okay, the non-basic variables in solution A is S1, S subscript 1, comma, S subscript 2. S1 and S2, right? Why are these two? Oh, the non-basic. Did the last question ask for the basic? Probably. X subscript 1, comma, X subscript 2. Okay, the table below shows the non-basic in C. The non-basic are those equal to 0. So that's going to be x1, x subscript 1, comma, x s2, s2, s subscript, dang, s subscript 2. Check. There we go. The feasible solutions are blank because they are solutions in which all the values are I want to say it's going to be F. In F, because all of the decision variables are positive. feasible solution. What is all three of my answers? So it wasn't this one. So is it, let's try, is it A, because the slack variables are positive? No. What's a feasible answer? View an example. A feasible solution of an E system is a solution in which all the values are decision variables and slack variables are non-negative. Okay, so A, B, E, and F. Because the... Okay. So in a E system, you cannot have negatives. As I'm going through, I'm understanding these. All right, so the table below shows the 6 basic solutions of the following. Use the basic feasible solutions to maximize P equals 4x1 plus 11x2. So which one of these? All right, well, I'm guessing it's not going to be A, because that would not give us that. I have to check B, because that's positive. And I have to check E and F. I'm going to say F. How can I do this with Desmos? Desmos, come over here. So let's open the graphing calculator. I just need to know what 4 times something plus 11 times something is. My first one is going to be 0 and 45, which gives me 495. So let's go 495. My second one is negative. That's negative. Let's do 45 and 0 over here. 0 and 45, which gives me 180. That's out. I think the answer is going to be 22.5 and then 30, which gives me, oh no, the answer is 45. So the maximum profit happens at 495, and that occurs when x1 is equal to 0 and x2 is equal to 45. I think that should be it. Nice. Okay, I'm starting to get the hang of this. Next question. The partially completed table shows the 10 basic solutions to the following system. In which solution, in basic solution H, which variables are non-basic? H should be S1 and S2. S subscript 1, comma, S subscript 2, because they are equal to 0. Which of the basic solutions A through F are non-feasible? Which ones are not feasible? So the ones that have a negative solution. So that's going to be C. That's going to be D, E, and F. C, D, E, and oh, I think F are all, because all the solutions are the solutions in which all the values of all decision variables are negative. Check. Are non-negative, are non-positive. I think it's negative. C, D, E, F, because the decision variables are non-negative. Negative. Oh, are not feasible, because feasible solutions are the solutions in which the variables are not negative. Ah, you dummy. Alright, we got that one, right? Alright, so what is the basic solution of G? G is... I don't know what to write here. Yeah, show the non-basic variables g2 and s3. That I got. I see those two zeros, which means that x2 equals 0 and s3 equals 0. So the equation is x1, x2, x3. The first equation says x1, x2, s1 equals 28 by substituting x1 equals 0 and yields that x1 plus s1 equals 28. The second equation gives me that. The third equation gives me that. That means that because equation 3 has only one variable, the best way to solve this system is to start by solving equation 3 for x1. And you get x1 is equal to 16, thus x1 is equal to 16. Substitute x1 into equation 1 to solve for s1. S1 is equal to 12, thus S1 equals 12. But how does that help me with, substituting x1 into the second equation gives us that S2 is equal to 4, thus S2 equals 4. Oh, I need the number. I get it now. I get it. So if I look at column G, let's see. X2 is 0 and S3 is 0. So that's going to be a 0 and that's going to be a 0. All right. So now let's see which one of these equations is going to be easiest. This is X2 and S3, right? X2 and S3. X2, S3. So very easily 5x equals 40. X1 is equal to 8. Once I know that x1 is equal to 8 plus 0 plus something equals 28, s1 is equal to 28. Okay, and then now I have 3 times 8 is 24, plus 0 is 24, and then if I subtract 30 minus 24, that gives me 6. Oh no, at least one of your answers identified. I really thought I had. There's got to be a typo. There's got to be a typo here. 28 for S1. S1. Oh, it's 20. Not 28. X1 was 8. Yeah, 20. 20, not 28. There we go. All right. Convert the given I system into an E system using slack variables and construct a table for all basics from the physical solution. All right. Write the associated linear equation. Boom. So like we said, that's going to be 5x subscript 1 plus 2x subscript 2 plus s1, s subscript 1 is equal to 10. 0, 0, 10. 0, 0, not feasible, right? Because it's not feasible if there are feasible. Equation 2 0, not feasible. At least when your answer is incorrect, substitute the known values into the solution and solve for the unknowns. Let's solve in which the slack is non-negative is called a feasible. What is this going to be? I don't know what that one would be. 5. Oh, because if S1 is equal to 0, I get it. And then there's one more that's going to be 2. That's going to be 0, 0. That's also going to be feasible. I gotcha. I'm starting to just learn this. This is not something that's I'm used to. So what is this? This is going to be x subscript 1 plus x subscript 2 plus s subscript 1 is equal to 8. My second one is going to be x subscript 1 plus 5x subscript 2 plus s subscript 2, oh shit, plus 2, right, plus s subscript 2 equals 20. Okay. Now my equation is 0, 0, I think this is going to be 8 and 20, and this is feasible. If these two are equal to 0, if these two are equal to 0, x1, then that means this is equal to 8. And for s2, it'd be 0, 5 times 6, 40, so this is negative 20. And this would be not feasible, I think. Nice. If both of these guys are 0, then I need this. I need this one. So the first thing that I would do is I would plug it into here to figure it out, right? So that's 0. That's 0. That means that x2 is equal to 4. And once I have that x2 is equal to 4, this is 0, that's 2, then that's going to be 4. And this is feasible. Alright, so now here let's look at this. I have these two equations, x1 and s2. I'm sorry, x2 and s1. x2 and s1, which means x1 is equal to 8. Once I have that, I look at the second equation. 8 plus 0 plus what equals 20. 8 plus 12 equals 20. And because these are all positives, I'm sorry, non-negative, it is feasible. All right, last but not least, well, I'm not even sure how many of these. X2 is 0. X2 is 0 and S2 is 0. So those two are both 0. So that means that this is equal to 20. And then if I plug in 20 up there, 20 plus something equals 8. That's going to be a negative 12. And this is not feasible. Last but not least, if S1 and X2 are both 0, I think this is negative 5. Oh, wait. I have x1 plus x2 is equal to 8. x1 plus 5x2 is equal to 20. If I subtract them, I get that negative 4 equals negative 12, which gives me, this is going to be equal to 3. Once I have that's equal to 3, 3 plus what? 5. And this should be feasible because they're all positive. Or non-negative, I'm sorry. Yeah, cool. Alright, so graph the system of equations from the boom, and then click the act. Alright, so let's blow this guy up. So here, x plus y is less than 6. So x1, y1 is less than 6. So here's x1, here's y1, and then let's strictly go less than. Then I know that my second equation is going to be 12 and 5, 4. There's 4. And then this is again less than, so we're going to go on that side. And then last but not least, this is all greater than 0. save. Check answer. So I'm gonna take, how do I gotta delete these, delete that, delete, delete, and then I just need that line, I need that line, I need this region to be shaded in, save, and check. There we go. Cool. List the corner points of the feasible region. So I got 1, 2, 3. 1 is going to be 0, comma 4, comma. The next one is, what's that point right there? 3, 3. Looks like 3, 3. 3, comma 3. And last but not least, it should be 6, 0. So let's do parentheses. Let's go 6, comma 0. And let's check those. Using the graph in the previous step, find each corner of the feasible region. Recall that all feasible region is the shaded region. So where did I mess up? 0, 6. No, 6, 0. 6, 0, 3, 3, 0, 4. That is 1, 2, 3. 1, 2, 3, 3, 6, 0, 0, 4, comma, comma. Where did I mess up? I'm gonna see what the answer is. Oh my god, I forgot 0, 0. Oh my goodness. That's annoying. That is so ridiculously annoying. Wow, I forgot the corner. Okay. Verify that the corner points of the feasible region correspond to the basic feasible. The basic feasible solutions are the basic feasible solutions are 0. They gotta be all positive. So let's see. 0. Nope. Nope. Yep. Yep. There are 4 answers. These solutions correspond to the corner points 0, 0, 6, 12, 0, 4, 2, 0, 3, 3, 0, 0, 6, 0, 0, 6. Cool. Graph this system. I'm guessing it's going to be very similar to the last question. So let's do this. Alright, so 42 divided by 7 is 6. 42 divided by 3 is 14. There's the 1. This is there. This is there. And then this is when that's 0, when y is 0, x is 13. And 13 divided by 2 is what, 7.5? And the region is in here. Check answer. 42 divided by 7 is 6. 42 divided by 3 is 14. Let's see, that's 0, 0, 6, 14, 0. This one should be 13, 0. And this one is going to be 0.5. Okay, and then we have, obviously, this is our line 0, 0. This is our line there. Oh, man. I'm really not sure where I'm... Determine the region that should be shaded. Your answer... My top line is off? Oh, because 13 divided by 2 is 6.5, not 7.5. Oh my goodness. That was a brain fart. I'm gonna do that one over. Alright. So let's see this. Okay, so if this is 0, that's 4.5. So 4.5 would go right clear. 4.5 is right there. And then 45 divided by 3 is 15. So that should go right 14, 15 right there. We're going to have our y-axis. We're going to have our x-axis. And then we have the second equation, which is 24 divided by 3, which is 8. 8 to 8. And then the shaded region should be on the inside. Save, check. There we go. List the corner points. So this is, there's 1, comma, 2, comma, 3, comma, 4. So the easy one, last one is 0, 0. Then we have 0, I think that's 4.5. And then I have, what is that? That's going to be 15 and 0. And last but not least is this little intersection point. What is this little intersection point? That's 4, 5, 5, comma 3. So let's go 5, comma 3. Check answer. No. Something here is just off. 0, 0. 0, 4.5. Not 15, 0, 8, 0. 8, 0. There we go. The basic feasible solution is everything must be positive. So there's 1, 2, 3, 4 solution. I'm going to go over here. So at 0, 0 it's possible. At 0, 4.5 it's possible. At 0, 8 it's not. 8, 0 it's possible. And 5, 3 it's possible. So there's 4 answers. So the basic one has 1, 2, 3, 4 solutions. These solutions correspond to the corner points of the given graph. Okay, for a standard maximization problem in standard form, which two decision variables explain why the feasible region is not empty? Yeah, I was gonna say that makes sense. You answered correct answer. The point 0, 0 will always satisfy the problem constraints for max standard. Oh, so it's the point 0, 0 always satisfy. Okay. If that is one of the problem constraints in the standard problem, explain why the maximum value of the, because the constraints means that the feasible region is non-empty. No, the region is bounded. For any of the feasible region bounded, the maximum problem will always exist. Yeah. If it's bounded, there's a maximum problem. All right, solve the given linear table below. Okay, so select the correct choice below, and if necessary, fill in the answer choices. Feasible, yes. No. So this, I think, what do I do with the methods? Do I add them? P is x1 plus x2. So obviously this is not going to be a maximum profit. 0, 3 would be 24. 15 times 6 is a lot bigger. That's a huge number. So I really got to compare this one and this one. 4 times 2 is 60. That already is 90. So I'm going to go with that one. The solution is when it's 6, 0, 0, 6, and my profit is 15 times 6 is 90. There you go. Yeah, it's starting to make a little bit of sense. It's just those weird variables, and it makes you have to like think a little bit. All right, explain why the linear program problem has no optimal solution. Has no optimal solution. So 4x. Oh, because this is there's no optimal solution because I think it's this one. Because every point is that nope. It's unbounded. Correct answer. The free is unbounded because every coordinate. Oh, that's what I. Similar question. I knew that it was unbounded. X2 is greater than 0, where x1. Yep. Basically, we're saying y equals mx plus b. And it's a line, so if there's no second point, it's going to be forever bounded. All right, explain the linear program has no optimal solution. So here, that's that. This is less than 4. This is less than 16. It's bounded. I mean, I could look at this, right? We should be able to look at this. So let's take a look at what this graph looks like. Let's go here, and then where's Desmos? Just go. Desmos is right there. Here, Desmos. There we go. All right, so let's take a look at this graph because I'm starting to really understand this. So if I do negative 4, negative 4x plus y is less than or equal to 4. Let's see. Let's see if we can connect this. And then let's say that we have 4x minus 5y is less than or equal to 16. So the problem here is that we're literally talking about this region, which is unbounded. So the phi is unbounded. So, and the coefficients of the function are positive. So there's, okay. It's not that one. I think it's because it's positive, so it's forever going up. So you literally, yeah. You guys saw it. All right, so linear program problem has 7 decision variables. 1, 2, 3, 4, 5, 6, 7, and 8 problem constraints. How many rows are there in the table basic associated with this ESA? I believe you need to add them. K and M, there's 9 and 10, so then it's 10. Oh, you just add them. Oh, okay. So here, this is 8 plus 7 is 15. 15 choose 7. 15 C combination 7 is how many? G's. Oh, the value 6,435. 6435. 6435. Jeez. Rows. A linear program problem has 28 decision variables and 46. How many are there? What's 46 plus 28? Let's go back to Desmos. We can cancel that. I need 46 plus 28 is equal to 74. So it's 74C28. Give me a big number. 74C28. Combination 28. Let's see if it does it. Ooh, 1.5 times 10 to the 23. Jesus, it's a big number. Copy. Let's go right here. Use scientific notation. Use multiplication. What did I say the number was? 1.51. 1.51 times 10 raised to the 28. Was it 28? Raised to the 23. 23 exponent. Oh, oops, times 46. What? 46 plus 28. 46 plus 28, and then 20. 46 plus 28. 46 plus 28 is 74. 74, choose 28. Why'd I get that wrong? How did I... Here, 27, 54, you add them together. You get 81, choose 27. Yeah, what the fudge? 28 plus 49. 28 plus 49. 77. So I need 77. Choose 28. Two point 0, 1, 3, 6, 9, 12, 15. Okay, so let's do 2.08 times 10 to the 15. 2.08 times 10 raised to the 15. Oh my god. Why? This one's also wrong. Why? 7? I'm like, not even close. Here, you know what? Let me go here. Let me do a combination calculator. Combination calculator. Okay, how many objects are there? I have, no. Here, 26 plus 54. What's 26? 26 plus 54 is equal to 80. So I'm going to go 80 objects. I am picking 26 of them. 26. Calculate. My answer is 7.69 times 10 to the 20. 7.69. 7.69 times 10 raised to the 20. Alright, I think the Google calculator was wrong. I'm using a combination calculator and I got it right in the first try. That's all I need to know. Alright, and that is 6.1, an introduction to the simplex method, which do not think the simplex is simpler. Alright, good luck.